Okay, I'd like to talk a little bit more today about exponential growth. Say we have a colony of bacteria. And it grows exponentially. And we have the following pieces of data about that colony. Two days after the colony is started, the volume is 20 milliliters, and 5 days after the colony is started, the volume is, let's say, 30 milliliters. So 2 days after we start the colony, its volume is 20 milliliters. 5 days after we start the colony, the volume is 30 milliliters. What I'd like to do to begin with is find a formula that gives volume as a function of time since the colony was started. So find a formula that gives volume as a function of time since the colony was started. The first thing we have to do before we do anything else is define our variables. Don't expect your reader to understand magically because you used V that you meant volume and that you used T you meant time. Let's go ahead and do that definition. This doesn't have to be fancy. T equals time, T dash time, let T be time, however you'd like to write it, and I'll just write V equals volume. T equals time, V equals volume. We have to define those variables. And since we're told that the bacteria grows exponentially, we know that V equals a number, which I'm just going to call B, times another number, which I'll call A, raised to the power T. You could have used any two letters there. I'm going to write it like this. This letter is the exponential growth rate. This letter is, in this case, the V-intercept, where it intercepts the vertical axis. And we have two pieces of data about our function here. So when T equals 2, the volume equals 20. We can go ahead and plug 20 in for V and 2 in for T. And we have another piece of information. When T equals 5, V equals 30. So let's go ahead and plug both those pieces of information in. So I'm going to do this one first. T equals 5 and V equals 30. So 30 equals B times A to the 5. And for this one, so all I did is I put 30 in for volume. And when the volume's 30, the time is 5. So I put T equals 5 in there. And when T equals 2, V equals 20. So I can write 20 equals B times A squared. What we want to do is come up with a formula, which means we have to know these two constants. When you have a line, y equals mx plus b, you can say you know what that line is once you know what the slope, once you know m, and the y-intercept, b. There are two constants there you have to solve for. It's the same here. We have to figure out what these two constants are. So we have two unknowns. It's fortunate we have two equations. When you have two equations and two unknowns, you actually have a shot. I want to take these two equations and figure out what a and b are. And there are a variety of ways of doing that are variations of things that you learned in previous courses. You could, for instance, solve for b in the second equation and plug it into the first equation, the method of substitution. I'm going to do something a little bit more slick that I think is nice and easy in a case like this. I'm going to take the first equation and divide by the second equation. So 30 divided by 20, that's 3 over 2, that's 1.5. And if I take this and divide by this, the b's cancel out entirely. A to the fifth over a squared, you know that when you divide powers, you subtract exponents. So this is a 5 minus 2 is 3. So a cubed equals 1.5. So that tells me right away that a equals the cubed root of 1.5. We can put that into a calculator to figure out that a is approximately equal to 1.145. So now I know that v equals b times 1.145 to the t. And to figure out what b is, I can go ahead and just plug in either of these 2 points. I'm going to use this one because the numbers are smaller. So 20, I'm putting v equals 20 in, equals b 1.145 to the 2. There's only one more unknown there, b, and so I can use this to work it out. So b is equal to approximately 20, approximately equal to 20 over 1.145 squared. And again, we can use our calculator to figure out that b is approximately equal to 15.26. I know A, I know B. The only thing left to do is write down my answer. So the formula is V is equal to 15.26, that's B, times 1.145 to the T. I'd like to do one more thing with this problem. I'd like to find the volume after 20 days. We already have the formula here. Take a moment and figure out what you do. Yeah, you just go ahead and plug in t equals 20. So V is equal to 15.26 times 1.145 to the 20th, and that's approximately equal to, it's approximately equal to 228.9 milliliters. Make sure we put our units in the answer because there were units in the question. I'm going to tell you now, or ask you now, if at any point during these lectures I make an arithmetic mistake, I hope you'll forgive me. I don't have you here to correct my mistakes, so I'm just going to do my best. But anyway, we were given two different data points, exponential growth, which told us that our equation looked like that. We used our two different data points, we plugged them both in to get two equations, and then we solved for our two constants, a and b. The exponential function has two constants in it, just like a line has two constants in it. And once we figured out what those two constants were, we knew that a was this and b was that. We just wrote out our exponential function there. Then when we were asked to find the volume of the culture after 20 days, since we already did all the hard work in A, all we had to do was plug in t equals 20 and solve for our volume.